Okay, on number 26 in section 3.4, you're asked to find the velocity of an object dropped from a height of 300 meters at the moment it hits the ground. All right, well, we have our fun, gosh, I can't spell. Okay. We have our fun formula that Galileo gave us for the position function. S of t is equal to S naught plus V naught t minus 1/2 gt squared. And so what we have to do is kind of figure out what's what. Now, in this case, S of t, the initial S naught is the initial position, and so you notice that it's dropped from 300 meters. So S naught is the 300 meters, dropped is the V naught, which essentially is going to be 0 here. So because you didn't give it any force. So this is going to be 300 meters plus, we didn't just zero this out, so it's just going to be minus 1/2. Now, since we're talking about meters, we're going to need to use the pull of gravity in terms of meters. This is going to be 9.8 meters per second squared, and then t squared. All right. Now, we want to know the velocity at the moment it hits the ground. So what we need to do is figure out when it hits the ground. Well, this is going to equal 0 when it hits the ground. The position or the height of the object will equal 0 when it hits the ground. So let's clean this up. This is going to be 300 minus 4.9 t squared equals 0. So t is going to squared equals, move your 300 and divide by negative 4.9. So it's going to be 300 divided by 4.9. And then you're just going to take the square root. Now remember, normally you have to invoke the square root principle. When you invoke the square root principle, you have a plus or minus, but t is dealing with time here, so it only makes sense to have the positive square root. So my little calculator here, if I do 300 divided by 4.9, and then I take the square root of that, I get 7.824 seconds. So, or I guess it rounded to 5, didn't it? 7.825 seconds is when it's going to hit the ground approximately. And, okay, so that's when. To find the velocity, you can either use a formula or take the derivative here. The velocity is just the derivative of the position. So if this is your position equation, the derivative of 300 is 0, and the derivative of this is just going to be negative 9.8 t. So you're just going to take this number that you got for t, so you'll do negative 9.8, and then I guess if you want to be most accurate, you could put the square root of 300 divided by 4.9 in there to get the velocity. And I've already got it stored here, so then I'm just going to do times 9.8, and I get 76.681 approximately. Yeah, and it's negative, but that just means it's going down. So down, it goes up and then it comes back down. So the negative is just the direction. So 76.681 meters per second is the velocity at the moment it hits the ground.